Welcome builders. So today we're going to be covering a topic that's mentioned in almost every single Build Sharper video, and that is the world of Git. So in course 0 we covered a quick overview of what Git is, but in this video I want to kind of go in more in-depth detail, specifically with the terminology, because when you get into Git, it has a whole almost vocabulary that comes with it that will become second nature to you once you get used to it. But when you're first starting out, it can be a little daunting. So we're going to start there. Then we're going to take a look at creating a repo on GitHub and then cloning that down to our local, creating a project, and then doing a commit, checking in that code, and pushing it up to the remote server. So without further ado, let's get started. Okay, so what is Git? Git is a version control system to track code bases at different points in time. And essentially that means it's going to track everything with our source code. It tracks all changes so that we can go back and we can either roll back to that point in time with the code, or we can do comparisons to say, okay, a month ago the code worked and here's a copy of that code, versus today maybe we have a new bug that was introduced. So by file I can go look and compare those changes. It also comes in handy with Git such that you can do what they call branching, where you're not all working on the same code base. You can branch off and each have your own local repository and then work independently without having to check into the server at all times. So our next term is repo or repository. And this refers to a collection of code that is managed in Git. And you can think of a repo as a project. For example, so if you're building a website and you want to check that website into Git, that would be a repo. And then say maybe you had a separate mobile app for your website. Well, that might be a different repo. So while technically you could have multiple projects in one repo, for instance, like a solution in Visual Studio can have multiple projects, you can have multiple projects in a single repo. But by default, I kind of think of it as one project per repo, okay? Working area. Okay, so a working area is where untracked and unstaged files live. And essentially that means it's your local environment. So the changes that you're making and the code that you're writing is all local to your working area, meaning that it hasn't been checked into the server yet. So in order to get the files there, they have to be staged, committed, and then pushed. So next is staging area. This is where the files are prepped for a commit, meaning that you've written the files on your local, some sort of progress has been made on your application, and you're ready to check that in to the server. So in doing so, we do what we call staging the files. And this is essentially bundling the files in preparation to push them to the server. They're being prepped for a commit. So of course the next term we're going to cover is a commit. This is a snapshot of your code at a particular time along with a message describing it. So as I said, with a staging area, we're selecting those files that are going to be included in the next push to the server. This bundle of files is called a commit, and with each commit you have to give it a description to label that commit. So that's the message that this is referring to. In general, if you're coupling your development with Git and Jira, Jira is an agile development system used for kind of project management. So if you have maybe a story in Jira that you're working on, you can label your commit with that story so that it kind of ties, here's the ask in Jira, and here's the code that corresponds with that story, okay? So next is a push, and this pushes those local commits to the remote repo. So as we said, when files are done, we can stage them, bundle them into a commit, and we can have multiple commits on our local without actually pushing them to the server. This is done through a push. So as we're working throughout the day, you could have multiple commits. You could have 20 commits in a day's work. of bundling files and preparing them to be synced to the server. But they don't actually get pushed to the server until you execute a push. And of course, the inverse of that is a pull. So this is where you're going to pull down the latest commits from the remote repo down to your local. So let's say you have a new feature that you're going to be doing. Well, the first thing you'll want to do is make sure you have the latest and greatest code. So you would execute a pull to go grab all the latest changes. Because let's say you're on a team of 5 different developers that are all working independently on this same repo. So there could be a series of commits that are up there on the server that you'll need to pull down to your local before you get started. Next is a fetch. This one kind of confused me when I first got started with Git, but essentially this is where you retrieve the current branches and changes in the remote repo, but you're not actually syncing the code down to your local. It just simply gives you a view of here's everything that's going on in the repo up on the server. So this can come in handy when you need to maybe check out a certain branch of, maybe somebody does a pull request, which we'll get to. They do a pull request and want you to review their code, and it's on some remote branch up on the server. So you would use a fetch to get that list of branches, and then you could check out that specific branch to go look at that code. Okay? Next is head. This is a pointer to the most recent commit on the current branch. This is what Git uses to know which snapshot is currently being worked on in your repo. So as I said, each commit is essentially a snapshot of your code, of the entire code base within your project. So a head just is a pointer to say which snapshot are we looking at. And by default, it's going to be the most recent commit. Next is main or master. Both are kind of used interchangeably, but essentially this is the first top-level branch in your repo. So when you create the repo, everything within the repo is a branch, including the first branch, which is by default called main or master. And from this, you're going to create more branches. So a branch is a line of development that is independent of main and master. So you can think of it as kind of independently, you get your own copy of the main branch, but you can work without impacting main until you do a merge. So this is kind of how you would do your development. You're going to have your initial commit into master that will be your initial code base. From that, you're going to have branches where you'll work on certain features, and then you would do your commit, you would do a pull request, and then you would finalize that with a merge back into master. So ultimately, you want master to be your production copy of your source code. So whatever's running in production is going to be in master. But to get there, you're going to have to merge up these feature branches into master. So of course the next is feature branch. This is a branch dedicated to the development of a new feature within your application. So let's say we needed to have a new login feature for the application where users can log in. If you're the developer that is working on this feature, you would create a branch specific to that functionality. This would be called a feature branch. Now this differs from other branches because let's say you need to do a hotfix. So your application's running in production and you find a bug and you have to fix it today. But your code is kind of in pieces right now because you have all these feature branches and several different developers that are working on these different features. So your application isn't necessarily in a state where it's ready to go to production. What you have to do then is branch off of master, which again we said is a copy of your production code. So you could branch off of master, create a hotfix branch, make your fix, merge that back into master, and then use that as your next release. Okay? And we're going to illustrate this on the board to kind of show how this works. I know it can get confusing with all the branches and merging and all of that, but it really is a powerful tool, and it's actually one of my favorite things about using Git. So next is a pull request. This is a request to merge a branch into another branch. Usually, this is a feature branch that needs to be merged into master. But as I said, it could also be a hotfix branch that needs to be merged back up into master. Or maybe your branch is 2 or 3 layers deep of like there's one overarching feature that gets created, but then that feature could have sub-features within it, which could be sub-branches below that. A pull request is simply taking a collection of commits that have been pushed up to the server onto that branch that you're working on, that feature branch or that hotfix branch. Now, when that needs to be merged back into master or whatever parent branch it was originally branched from, this is managed through a pull request. And with that usually comes a code review. So when creating a pull request, you can then select who you want to be on there as a reviewer. That reviewer then gets notified so they can log in, look at your code changes, they can make comments, and they could reject the pull request to say, no, this still needs work, and here are my comments. Per line item, it's actually really cool. You can say on line 53, you need to change this, or have you thought about doing things this way? Like I said, then they can mark it as needs work. The developer gets notified and then can go in and make their changes. Once everything's good to go, they approve the pull request and the code can then be merged up to that next branch. All right, so merge. This is joining the commit history of one branch to another. So like I said, say we have a feature branch that needs to be merged up into master. We're going to take all the commits that have been done on that feature branch and then merge them up to the master branch, which is essentially syncing that feature branch into master, so that now master has all the code that was developed in that feature branch. Or in the case with a hotfix branch, whatever bug fixes you did in that hotfix would then be merged into master so that it reflects the fixed code. Okay, and then finally is cherry pick. This one's a little confusing, but it's actually really powerful. So as we said, if we have a hotfix, we're essentially making a branch off of master, which is a copy of our production code. So we're doing a hotfix off of that. But down here, we have a feature branch where we're working on, like we said, maybe it's a login feature where we need to log the user in. But if a bug fix is made way up in master, well then that isn't reflected down in my feature branch. I have to pull that commit into my feature branch so that it doesn't get stepped on when I then merge my code up. To do this, we're going to cherry pick. Cherry picking is taking a commit from another branch and applying it to another. So once that hotfix is applied to master, that commit I can then cherry pick and move it down into my feature branch. So I'm going to hop over to the board and let's visualize some of these things. Okay, so here we are on the board, and as we said, every repo has one branch to start with, and this is either called main or master. So let's create, I'm going to go with master. Let's call it our master branch. So here we go. Okay, and you can totally do all of your development with one branch. You don't have to do branching, but I highly recommend it, especially as your code gets more and more complicated. And if you bring in more developers, you're going to want to use branching as well. So at the very simplest, you would want to have master be a copy of your production code. And then you'd want to have some sort of working branch to have whatever you're currently working on. That way, if production goes down or you have some sort of production bug impacting your users, you could create that hotfix branch fix your production code while also saving all the work that you're doing on your local, in your local development environment. Okay? So let's say, for example, we have our master branch, and now we're going to want to have a separate branch, let's say for that login feature. So we're going to branch off of master. This is going to be feature 1, and this is created from a copy of master at that point in time. So the code base that gets moved into feature is that snapshot of master. Okay? Now I can work independently within feature 1 without affecting master until the code is ready. Once the code is ready, I'm going to stage those files and do a commit. But again, the commit is only local to my environment. I have to do a push to move it into my feature branch. So actually what we're going to have is a working copy or local copy of this feature branch. So, and I'm going to illustrate this with a little bit different color. So let's say this is blue for my local, and then the black indicates the server or the remote repo. So I'm working within this local working area, and I'm going to have my files that I'm working on. And with those files, they would get staged, and I'll have one or more commits with those files. But again, this is all happening within this blue ring. This is my local working copy. The server knows nothing about my changes yet. To do that, I'm going to execute a push, which would push from my local up to the remote branch or the server. Now, if I then want the code from this feature 1 branch to move into master, that's where a pull request comes in. So let's say on our feature branch locally, we've created 2 commits. We have commit 1 and commit 2. So this is all local. Now I need this to go up to feature 1 branch on the server. So to do so, I'm going to execute a push. So this would be a push. Actually, this would be a push from our feature branch locally up to the feature branch on the server. Okay? Now, in order to get these changes, and with this push, let's illustrate, these commits are coming with that push to push it up to that feature. And again, each commit is essentially a snapshot of the code. So we're moving this code from the local up to the server. Now, to get it from our feature branch up to master, we're going to be doing a pull request. So let's create a new label here. This is a pull request. And with that comes these commits, which can then be merged into master. Now, to make things a little bit easier to read, I've kind of color-coded things so that you can see everything in blue is our commits. This is the code that we're trying to push between branches. And then the yellow indicates the push, where we're pushing from our local to the remote or server repo. And then the purple indicates the pull request, where we're requesting, can we merge this set of commits into the master branch? Okay? So, I'm going to remove these for now so that we're back to only our branches. Okay? So, I've got my feature 1 branch and my local copy. Now, let's imagine something goes wrong in production. There's a new bug that popped up and it's affecting all users. No one's able to get into the system. and I'm still working on feature 1, so the code is in pieces right now. It's in no state to actually bundle up and deploy to the production server. So to make a bug fix, I'm going to branch off of master. I'm going to create what's called a hotfix branch. So this would be a new branch over here, and we'll call this hotfix 1. And this is going to follow the same pattern. With hotfix, I get my own local working area where I can then work with a copy of the code from master. So with Git, you can also only check out one branch at a time. So all of my changes here are going to be saved inside of this branch. This is known as shelving. So I can shelve these changes into this branch so that they can be retrieved later. So I'm going to shelve feature 1 for now. And you can think of that literally as I'm going to take this code, bundle it up, and put it on the shelf. And then I'll go retrieve it from that shelf later when I'm ready to start working on this feature again. But right now, I have a hotfix to make. So I need to fix this bug in production. So now I've got my local working copy of hotfix, which is created from a copy of master, which is that production code. I then make my code fixes, stage those files, do a commit, then I do a push of those commits back up to this remote branch. Now, to get this code from hotfix up to master, I have to do a pull request. So I would select those commits that were involved in this code fix, create that pull request, and then I can select a colleague that could review that code and approve the merge into master. Once that code is merged up, I can then do a build and deploy to production, and this all happened here independent of feature 1. So now, once hotfix is done, I can then unshelf feature 1, take it off of that shelf, recheck that code out, and I have it on my local. So now, let's get into cherry picking. So now that we've gotten our hotfix up there into master, we now need to sync this down into feature 1. Because let's say it's a shared file that's in feature 1 that needs this fix as well. To do that, we're going to do a cherry pick. So we can illustrate this here. This is going to be a cherry pick of, let's say it was commit 3, is the snapshot of the code that we're needing from master. So that would then take this code and merge it into our feature branch. So now, since I'm working on feature 1, I can pull in the hotfix commit that was made so that whenever I push feature 1 up to master, I don't step on that fix. So for example, let's say the login page was broken in production before. It was fixed with the hotfix branch. And when I re-push that login page from feature 1, I don't want to reintroduce that bug. So to prevent that, I'm cherry picking that commit that was made in the hotfix and applying it to my feature branch. So now that we've looked at kind of the illustration of branching and the use of commits, pushing, pull requests, and cherry picking, so now we're going to hop over to GitHub, actually create a repo, and then clone that on our local, go into Visual Studio, create a little project, and actually look at Git in action. Okay, so the first thing we're going to do is go create a repo on GitHub. So we're on github.com. Let's go to new, and we have to give it a name. So let's just do Git demo, and we can give it a description if we'd like. We can choose whether or not this is going to be a public or a private repo. Now it has down here a .gitignore file. The gitignore file allows you to specify file extensions that will be excluded from your repo. For example, we wouldn't want to check in like a .exe file because that's a compiled binary file that's going to actually eat up a lot of room in your repo. Similarly, like DLL files, files that you build from your project, you don't really want to include those either. But one of the handy things you can do with GitHub is you can specify a template. And in our case, we're going to be using the Visual Studio gitignore file, which means that all of the files that Visual Studio uses to build the project, like the object files, the files in the bin folder, things like that, will all be excluded by default when using this .gitignore file. And next, you choose a license. By default, I use the GNU generic public license. Okay? And let's create it. So now that we have a repo, we're going to clone it on our local. We could use the command line to do this, but for our purposes here, we're just going to be using SourceTree, which is a visual tool for Git. And especially when you're new to Git, it comes in handy while you get used to all the terminology and kind of the commands that need to be run. I have found that using a visual tool is much easier to use. So first off, what we're going to do is go over to SourceTree. It's sourcetreeapp.com. Download this, install it. They have it for both Mac and Windows. And I'm going to get it pulled up here. Okay, so we're going to clone this repo on our local. So to do that, in GitHub, we're going to go to Code, and what we're looking for is to copy this address here. This is the address to our Git file. So copy this, and now in SourceTree, we're going to go click on Clone. The first path it's looking for is the repo path, which we're going to paste from GitHub. It's now looking for a local path on our local machine, and click Clone. So now we now have that local working area where we can go create our project in Visual Studio. Okay, so I'm in Visual Studio and I'm going to create a new project, and we're just going to do like a hello world. So I'm going to create a console app, and the path of this is going to be the same path that I specified when I cloned my repo. So this is a simple hello world. We can run it here and make sure it works. Hello world, looks good. Okay, so now let's get this checked into our repo. So I've got our repo open here in SourceTree. We can see we've got 3 unstaged files. These are the files that just got created when we created our little console app for Hello World. We've got a solution file, a project file, and our program.cs. And what we're going to do now is prepare these into a commit that we can now push up to our branch. Okay, so I'm going to stage all. I now have my staged files. As we said at the beginning, a commit consists of a collection of files and a message. So we have our collection of files here, but now we have to give it a message. So we're just going to say initial commit. So we've done our commit. Now, up here up top, we see push now shows that we have 1 pending push, which means that we just made a commit, but it's still local. We're still in our local working area. We now have to push this to the remote branch. So we click push, and we're going to the main branch and hit push. Okay, so now that we've done our push to the server, I can come back here on GitHub and I can see I now have a console app 1 in our repo. I can click into this. I can see there's my solution file, there's my project file, and my program.cs. So everything that we just pushed has now been synced to GitHub. And we can see everything is labeled with this initial commit as we put on our commit message. So now Now we have our initial commit checked into our main branch. But now let's say we want to make a new feature branch. So let's say we wanted to say hello Chris instead of hello world. So that's going to be the feature we work on. And instead of working directly at a main or master, we're going to create our new feature branch to do these changes. So let's do that. So back in source tree, we've still got our Git demo open, and we can see we only have one branch right over here, the main branch. So we need a new branch. So click branch. It'll say the new branch name. Let's say we want to call this, by default, the naming convention I use is name. So I'm going to do C Bryant. And then I tend to do either feature, like /features or /bugs, based on what I'm working on. So in this case, we're going to do a feature. So C Bryant /features / let's call this hello-Chris. That's what the feature branch is going to be called. We're going to use a working copy of the parent, which in this case is going to be main or the master branch. And then we can have a checkbox for check out the new branch. So by default, when we create a new branch, it's going to go ahead and change our repo to be pointing at this new branch, which we do want. So now click create. We can see over here on the branches now, we still have main, but now we have this hello Chris branch. And I can then switch between branches simply by right clicking and doing check out main, or right click and check out hello Chris. But we're in hello Chris, so let's go ahead and make our changes in Visual Studio. Okay, so we're now back in Visual Studio, and my change, it's a big change. We're going to say hello Chris. Let's run it, make sure it works. And it does. We're good. So now we're back in source tree, and we can see program.cs is now back in our unstaged files. That's because that has changed since this branch was created. So in fact, we can right click on it and go to external diff, and it will show us what has changed. So we can see the red line is what it used to be, and the green line is what it is now. So we have changed hello world into hello Chris. Okay? So I'm going to stage all. This is going to move this file into our staging area, preparing it to go up with the commit. So the last step is to give this commit a new message, and we could say something meaningful like changed world to Chris. Okay? And we have the option to push the changes immediately, which in our case we do. So I'll click commit, and looks like we're good to go. So now that I'm back in GitHub, I'm going to do a refresh. And I can see Program CS still says that initial commit. It doesn't have my new commit message. But that's right, because we check that into our hello Chris branch, not into the main branch. And we can see here, we have multiple branches. So if I were to switch over to this hello Chris branch, here I can see where I changed world to Chris. Okay? But how do I get that up to my main branch? Well, for that, if we were in a multi-developer environment, we would do a pull request. We would like to give other developers the opportunity to review our code before we merge it into that main branch. In this case, we're the sole developer, so we can do a direct merge without a pull request. So let's go over to source tree and take a look at that. So we're back in source tree. You can see we still have the hello Chris branch checked out, but we want to merge. So let's go back to main and check out main. Okay? Now we're looking to do our merge. So we can see our commit history here. And I'm going to click merge. Now it's going to merge that hello Chris branch onto my current branch, which is main. So I click OK. And now I do a push, which is going to push these changes up to the server from my local working area. Now, let's go take a look on GitHub. We've still got our main branch selected. Let's do a refresh. And there we go. Now our changes have been pushed to the main branch. And we can see it says, "Hello, Chris." And that's it. You now have everything you need to get started using Git on your projects. We started out by covering all the terminology. Things like, what is a repo? What is a commit? What are unstaged versus staged files? What is a branch? What is a feature branch? What is a cherry pick? All these things we've covered that you can now add to your tool set. We then took a look at source tree and how to clone a repo on our local, and then create a new project in Visual Studio and get that checked in and pushed up to the server. We also created a feature branch, made a tweak, and then merged that into our main or master branch. Now, as I mentioned, a lot of developers use the command line to control Git. I have found, though, that when learning it, it's a lot easier to do so using a visual tool like SourceTree. But as you get more and more familiar with the process and the commands, you'll probably find that you prefer the command line as well. Now, as you may have guessed, there is no homework on this video, and that's simply because, as we said, most every other video on Build Sharper asks you to download the repo and clone it on your local. So with that, I invite you to go check out the next course, download the repo, and get started with Git. We'll see you next time.